everyone, in this video I want to talk about how to find the power series for h of x equals 6 over 5 plus x. Now there are some known power series that we can use here, and one that has a similar form is the known power series for the function 1 over 1 plus x, and that, if you look it up on Google or in your favorite calculus textbook, it is the sum, as n goes from 0 to infinity, of -1 to the nth power times x to the n. So I have something that looks kind of similar. I have a 6 in my numerator instead of a 1, so we'll need to adjust that. So let me fix that. I'm going to factor out a 6. And now in my numerator, I've got a 1. So that's going to match up nicely. And then in my known series, I've got 1 plus x, or 1 plus some unknown weird quantity. So I really do need a 1 plus something. So instead of a 5, I need that to be 1. So I'm going to factor out a 5 from my denominator. And if I do that, I'm going to be left with 1 plus x over 5. And that's okay, because the general format here is, 1 over 1 plus whoozy-watsy or whatever, your unknown quantity. It could be u, it could be a banana, it could be x. So the fact that I've got x over 5 here, I don't really care. In my formula, I'm just going to replace, whoozy-watsy wherever I saw the x. So that's going to work out just fine. So let's finish this problem off. Out in front, I'm going to have 6 over 5. And then instead of 1 over 1 plus x over 5, I'm going to have the sum, as n goes from 0 to infinity, -1 to the nth power times whoozy-watsy, or my unknown quantity, to the nth power. And in this case, my unknown power, or my variable expression, is the x over 5. And that's it. That's the final answer. Now, you could put this in a different form. You could bring your 6/5 back inside the summation notation. And so if you do that, -1 to the n is unaffected. And then I'll have in my numerator a regular old 6 times x to the nth power. And then down in the denominator, I've got 5 times 5 to the nth power. And that's a little bit awkward to write, so I might just write 5 to the n plus 1. So 5 to the n plus 1. And that's what I would present as my final answer.